Hello and welcome back. Today we're doing section 1.2. We do a quick little review of intercepts, a little bit of work on symmetry, and graphing a few key equations. So we'll get into finding intercepts algebraically. In section 1.1 they introduced how to approximate intercepts using the calculator. Again, unless the problem specifies otherwise, we're looking for exact answers algebraically. So we'll go with y is, I'll go with x squared plus 2x minus 14. So we have x-intercepts and we have y-intercepts. Because this is a function, we know we have the possibility of at most one y-intercept. X-intercepts, because this is a quadratic, we could have 0, 1, or 2 x-intercepts. The y-intercept is a little bit faster to find. All y-intercepts happen when x is equal to 0. Just picture again what it would take to be an intercept. Every single point on the y-axis is 0 comma something. We have 0, negative 2 down here, 0, positive 3 up here, etc. Anything on the y-axis is 0 comma something. So as soon as you see y-intercept, you think x equals 0. So y is 0 squared plus 2 by 0 minus 14. So y is negative 14. So make sure you turn that into an ordered pair. So 0, negative 14 would be our y-intercept. X-intercepts, same idea. If it's an x-intercept, that means it's touching the x-axis, which means its y value must be 0. Otherwise, we've gone too high or too low to touch the x-axis. So we have 0 is x squared plus 2x minus 14. Quick check for factoring, and I'm not finding a pair of integers that will multiply to negative 14 and add to a positive 2. So then that leaves completing the square quadratic formula. With our leading coefficient of 1 and an even in the b spot, completing the square would be a little bit quicker. So we'll add 14 to both sides. Remember, that's to both sides, not just to one side. A lot of times I'll see students end up missing points for things like that, of a plus 14 on one side and nothing on the other side. Make sure you have a balanced equation. So 14 is x squared plus 2x. So then half of the middle coefficient and square, and half of 2 is 1. 1 squared is 1. We'll add 1 to both sides. So 15 is x plus 1 quantity squared. Square root of both sides, plus or minus on the side with the constant. So x plus 1 is plus or minus root 15. 15 doesn't have any non-trivial perfect square factors. It has 1, but that one's trivial. It doesn't help us get any more simplified than that. So x is negative 1 plus or minus root 15. And again, don't forget to put those into ordered pairs. So this would be negative 1 plus root 15, comma 0. And we also have negative 1 minus root 15, comma 0. So that's finding our intercepts algebraically. And that was with a quadratic, but any algebraic equation asking for intercepts, those are the concepts that we're using. All right, so next we're looking at testing for symmetry. So we have different types of symmetry. So if we have an equation that's symmetric about the x-axis, I'll call this point, let's say x naught, y naught. If we were symmetric with respect to the x-axis, WRT is common abbreviation for with respect to. That means basically I would fold this thing across the x-axis and form a new point that's the mirror image of this first point. So notice if I do that, the x-coordinate didn't move. So the x value is still x naught. The y value, however, instead of going up whatever number this is, we're going down whatever number that is. In other words, we find the opposite. So if we have something that is symmetric with respect to the x-axis, opposite of y will return the same thing as y. Same idea if I have a point, again we'll just call it x naught, y naught. If we reflect over the y-axis, this time I would keep the same height. If I fold it across the y-axis, the height doesn't change. So the height is still y naught. However, instead of going to the right x naught units, I went to the left x naught units. So if we are symmetric with respect to the y-axis, notice it's the x that changes signs. And then the last thing we do is try to fold it over both, and that is symmetry with respect to the origin. So if we have a point that is symmetric with respect to the origin, we basically have folded it twice, once across the x-axis, once across the y-axis. And the order on those isn't important. We could have folded across the y-axis first, the x-axis second, and then here's our new point. So notice both signs then would flip. I didn't leave myself enough room to finish that. There we go. Opposite of x naught, opposite of y naught. Both signs flip for a point that, or a graph that is symmetric with respect to the origin. Now, as far as what that looks like in equations, let's take a look at y is x squared minus 25 all over x to the fourth plus 3. So if we're looking for symmetry with respect to the, we'll start with x-axis. If it's symmetric with respect to the x-axis, flipping the sign on the y should still give me the same equation. And in fact, this one does not. If we multiply both sides here by -1, we get y is opposite of x squared plus 25 over x to the fourth plus 3. If you're wondering why the signs in the denominator didn't change, remember -1 you can think of as -1 over +1. We multiplied the bottom by +1, not -1 over -1. Since that's not equal to the original, this is not symmetric with respect to the x-axis. Next, we'll try out symmetry with respect to the y-axis. Folding across the y-axis, it's the x that changes sign. The y stays at the exact same height. So opposite of x squared minus 25 over opposite of x to the fourth plus 3. This one, there's a little bit of simplifying we can do. So opposite of x times opposite of x is x squared. And I have an even number of negatives being multiplied in the coefficient at the bottom as well. Even number of negative ones multiplied together give me a positive 1 coefficient. This, notice, is back to the same as the original, so this is symmetric with respect to the y-axis. And then we test for the origin. We flip both sides and see if we can come across the same thing. So opposite of y then equals x squared minus 25 over x to the 4th plus 3. So y is opposite of x squared plus 25 over x to the 4th plus 3, not equal to the original. So this is not symmetric with respect to the origin. We always wanted to get back to the exact original. A common question with this as well, they may ask us to find all intercepts. If they ask us to find all intercepts and test for symmetry, that one is pretty quick to do. Finding the intercepts in this case are y-intercept only happens when x is 0, so y is 0 squared minus 25 all over 0 to the 4th plus 3, so negative 25 thirds. So our y-intercept is negative 8 and 1 left over, negative 8 1/3, 0. My apologies, 0, negative 8 and 1/3. X-intercepts happen when y is 0. So here we would multiply both sides by the x to the 4th plus 3. There, my apologies, I'm going to just finish it up here. So 0 is x squared minus 25. So then 25 is x squared, square root of both sides, plus or minus on the side with the constant. So x is plus or minus 5. So our x-intercepts are 5, 0, negative 5, 0. All right. So same question again. Find the intercepts and test for symmetry. This time we'll do y is x cubed minus 25x. X-intercept or intercepts, those happen when y is 0. This one is solvable by factoring. Common factor of x. So x by x plus 5 by x minus 5 equals 0. So we have the product of 3 factors ending up in 0. So now we just have 3 possibilities to set to 0 and solve. So x is 0, or x is negative 5, or x is positive 5. So 0, 0, negative 5, 0, 5, 0 are the 3 x-intercepts. The y-intercept, hopefully you notice we already have it. 0 cubed minus 25 by 0 is indeed 0. So the origin is both an x-intercept and a y-intercept. Next up, symmetry. we'll start with x-axis, so opposite of y, and I want to know, is that the same as x cubed minus 25x? So symmetric about the x-axis. Again, picture if you're folding something across the x-axis, the x value stays the same, the y value changes from positive to negative or negative back to positive. This one we could multiply both sides by -1. And y is negative x cubed plus 25x. That is not equal to our original, so we do not have x-axis symmetry. So next we'll test for y-axis symmetry. That flips the sign on our x's. So y is opposite of x cubed plus 25x, not equal to the original. So we have no y-axis symmetry. So last we test for the origin. So opposite of y equals opposite of x quantity cubed minus 25 times opposite of x. So opposite of y is opposite of x cubed plus 25x. So just negative by negative there is a positive. Odd number of negatives. Product is negative. And either multiply or divide both sides by -1. So y is x cubed minus 25x. That is the same as the original. So on this one we do have symmetry with respect to the origin. All right, so I'll look through maybe one more of these guys together. So let's try y is 1 over x squared. So same questions, find the intercepts and check for symmetry. X-intercept or intercepts, those happen when y is 0. 0 is 1 over x squared. Multiply both sides by x squared. And 0 equals 1. That is a contradiction. So that tells me there are no x-intercepts. Another way to spot the fact that we have no x-intercepts, if we end up with a square root of a negative number, that kicks us out of the real numbers. And remember, each axis is just a number line. Y-intercepts, those happen when x is 0. And this one again, this time we are undefined. So that tells me there are no y-intercepts. So this one will not touch the axes. Doesn't mean necessarily we don't have symmetry, so start with the x-axis. Flip it across the x-axis and it's your y that changes. So opposite of y is 1 over x squared. Multiply or divide both sides by -1. And y is -1 over x squared. That's not equal to the original, so we have no x-axis symmetry. And we check for y-axis symmetry. Fold it across the y-axis, and it is your x value that flips. You're staying at the same height. Yes, the parentheses are required there, otherwise we would get a different solution. So y is 1 over x squared. That is equal to the original, so this is symmetric with respect to the y-axis. And then we test for the origin. So opposite of y equals 1 over opposite of x squared. So opposite of y is 1 over x squared. Multiply both sides by -1. And y is -1 over x squared, not equal to the original. So this is not symmetric with respect to the origin. All right, so this next one, I'm going to put it up and suggest that you sort of pause the video and come back and make sure that it is your solution is the same as what we've come up with here. So we'll do 5x squared minus 3x plus 4 is equal to y. All right, so test that for intercepts and symmetry and unpause when you're done. Okay, welcome back. So x-intercept or intercepts, those happen when y is 0. So 0 is 5x squared minus 3x plus 4. So we'll check for factoring first, since that's a nice quick way to do it. Multiplying to positive 20 and adding to a -3, and I can't come up with a combination that'll do that. So completing the square, quadratic formula. Completing the square is definitely possible with this one. It would be a little bit messier since we have a leading coefficient that's not 1, and we also happen to have an odd number here. So this is a case where quadratic formula might be faster. So opposite of b, opposite of -3 is +3. Plus or minus square root, all that's from the formula, b squared. Remember, if you square a negative, you get a positive. Square a positive, you get a positive. Square a 0, you get 0. The number here is never going to be a negative number. You can get a 0 or a positive number, never a negative number in that spot in the quadratic formula. -4, you saw in the appendix why that number appears in our formula. Times 5 times 4, all over 2 times a, 2 by 5. So x is 3 plus or minus square root of, we have 9 minus 80, all over 10. So x is 3 plus or minus square root of -71 all over 10. The fact that I have a negative underneath the square root, that tells me right there that negative number under the radical, no x-intercepts. Y-intercept, that only happens when x is 0. So y is 5 by 0 squared minus 3 by 0 plus 4. So y equals 4. So 0, 4 is our y-intercept. Then on to our symmetry. So our x-axis symmetry, flip the sign on the y and see if you get the same thing back. So here I'll divide both sides by -1. So y is -5x squared plus 3x minus 4. That is definitely not equal to the original. So we are not symmetric about the x-axis. So then we can test for symmetry with respect to the y-axis. Flip it across the y-axis, and it's your x that is changed sign. So 5 times opposite of x squared minus 3 times opposite of x plus 4 is equal to y. So 5 times opposite of x squared will simplify to 5x squared. -3 times -1x is +3x. We still have our plus 4. We still have our equals y. And notice the 3's here. 1 is a minus, 1 is a plus. That means we're not equal to the original. So this is not symmetric with respect to the y-axis. And finally, symmetry with respect to the origin. Opposite of y equals 5 times opposite of x squared minus 3 times opposite of x plus 4. So opposite of y is 5x squared plus 3x plus 4. Divide both sides by -1, so y is -5x squared minus 3x minus 4. Definitely not equal to the original, so this is also not symmetric with respect to the origin. Okay, so that should be enough to get you started on the 1-2 problems. You can either go on to the Pearson My Math Lab and try the homework there, or you can do the book problems, section 1 to 1 to 10 all, I would recommend, 11 to 83 every other odd, and if you're looking for challenge problems, 87 and 88 ask interesting questions. So again, either My Math Lab version or the textbook version. I don't care which one you do. If you have any questions, please feel free to get in touch with me. Otherwise, I'll see you next time. Stay safe out there.